Hi everyone. Am I audible? Okay, let's start mathematical logic. Okay, so almost all the students have joined. Then let's start. And also, if you have any doubt while we are taking this while we are discussing this mathematical logic, if anyone has any doubt in any any part, if you do not understand, if there is something that you do not understand, then you can ask in the chat comment box, and I'm looking at the comment box after every 5-10 minutes. I will see the comment box and I will answer your doubt. Okay, so let's start the mathematical logic. This is very important from net point of view. So, and this is also a very easy topic. Okay, so let's start it. And because we are having this crash course, so we will focus only on the concepts from which questions questions will be asked in the net exam. Okay, so let's directly start our concept session, and we will see every concept, and for every concept we will take some examples, and we will understand that concept through examples. So first, the concept is, in mathematical logic we have two kinds of logic. In this mathematical logic we have two type of logic, and the first is propositional logic and the second is our first order logic. So the first is propositional logic and the second is predicate logic, or it is also called predicate logic, or it is also called first order logic. Okay, so the these are the two type of logics in syllabus. Remember, this is a different form of logic and this is a different form of logic. Every functionality, every facility, every concept that we have in propositional logic, we also have in predicate logic. But the predicate logic has some more functionality. It provides some more features. This predicate logic, this first order logic, it provides some more features. So first we will see propositional logic and then we will see first order logic. But remember, every feature that propositional logic provides, that feature is already present in predicate logic, but predicate logic provides some extra features. We will see what are those extra features and everything we will see. So first form of logic that we will start is propositional logic. This is the first form of logic we will start. These are basically different levels of logic. The first is okay, Pratibha, actually many students are South Indian, so that is why um, many of them do not understand Hindi. I can definitely teach in Hindi, but because of many other students who cannot understand Hindi, and because of that, this session is in English. Okay, so let's start this propositional logic. Now, in propositional logic, the first concept that we have is proposition. What is proposition? The first concept, the very basic concept. So this propositional logic is completely based on a concept called proposition. What is a proposition? This proposition is nothing but a statement. Any statement that you make, that is a like any declarative statement that you make, that is a proposition. For example, my name is Deepak Punia. Now this is a declarative statement because I am declaring a fact that my name is Deepak Punia and this is true. Okay, so this is a true fact. Now I can also say, for example, I can give you another statement, for example 2 plus 2 equal to 5. Now this is again a fact, but this is a false fact. Remember, this is again a fact, but this is false fact. So this is again a propositional statement. This is again a proposition. So proposition is nothing but a statement, okay, which is a declarative sentence, sentence. Basically, it declares a fact, okay, and it is either true or false, but not both. It is either true or it is false. Like for example, this 2 plus 2 equal to 5. It is declaring a fact that 2 plus 2 is equal to 5. That is the fact that is declared by this statement, by this sentence. This fact is false, so we can assign this truth value. This is known as truth value. We have two truth value. The one is true and another is false. So if the proposition is false, then we will say that this is a false proposition, and if the proposition is true, then we will say that it is true proposition. For example, this 2 plus 2 equal to 5, this is a false proposition. For example, 2 plus 2 equal to 4, this is a true proposition. So with this proposition, remember, with this proposition I can assign the truth value t. T means true, so I can assign this truth value true, and we will indicate this true with t, and we will indicate this false with f. So this 2 plus 2 equal to 5, this proposition has the truth value f, and this proposition has the truth value t. Similarly, this 3 plus 5 less than equal to 10, this proposition has the truth value t. So you can see, very easy concept. It is proposition. It is nothing but a statement that is either true or it is false, but it cannot be both. Okay, so that is the definition of proposition, and it is basically declaring a fact. Can give examples in Hindi for more clear if possible. Okay, तो हम ये कह रहे हैं कि प्रोपोजिशन जो है वो एक बस स्टेटमेंट है. आप कोई स्टेटमेंट अगर आप बोल रहे हो, तो अगर आप कोई फैक्ट डिक्लेयर कर रहे हो, कोई फैक्चुअल स्टेटमेंट आप बोल रहे हो, या तो आप कोई फॉल्स स्टेटमेंट बोल रहे हो या कोई ट्रू स्टेटमेंट बोल रहे हो, तो वो एक प्रोपोजिशन होगा. अगर मैं कहूँ कि माय नेम इज दीपक, तो वो एक प्रोपोजिशन है, वो एक ट्रू प्रोपोजिशन है क्योंकि मेरा नाम दीपक है. अगर मैं बोलूँ कि माय नेम इज अब्दुल कादिर, नाउ दैट विल बी अ false proposition, but it is still a proposition. Basically I am declaring a false fact that my name is Abdul Qadir. So you can see, basically this is a false fact because my name is Deepak. So you can see I am declaring a false fact here. So whatever factual statement you give, that factual statement is called proposition. Some statements are not proposition. Let me give you some examples that some statements are not propositions. Let's take this example. If I tell you, let's see this sentence, sit down. Let's see this sentence, sit down, sit down. Now this is not a declarative statement, this is a command. Remember, this is a command, this is not a declarative statement. Okay, so we can, like with this sit down, we cannot say whether it is true or false. So this is a command, this is not a declarative statement. For example, if I ask you, if I give you the second sentence, what is your name? What is your name? Okay, what is your name? Now this is a question. This is not a declarative statement. We are not declaring any fact here. This is a question. So this is again not a proposition. Now we can take another example. For example, we can see 2 plus x equal to 3. Now this is also not a proposition. Why? Because you cannot say whether it is true or false. The truth value of this sentence will depend on the value of x. So it will depend on the value of x. If I give x equal to 1, then you will say that 2 plus 1 equal to 3. Now this is a proposition. This is a true proposition. If I give x equal to 2, then you will say 2 plus 2 equal to 3. Now this is a, again this is a proposition, but this is a false proposition. So this is a proposition, this is a proposition, this is true proposition, this is false proposition, but this is not a proposition. Why this is not a proposition? Because the truth value will depend on the value of x. So we cannot assign true, you cannot assign true, right? Because it will depend on the value of x. Similarly, you cannot assign false because it will depend on the value of x. So that's why we can say that this is not a proposition. These are some examples how what is a proposition, what is not a proposition. So we have seen it, and now let's move on to our next concept. Now we have some propositions. So now we have some proposition. Let's assume I have a proposition and I will denote it with proposition P. Why? Because I do not want to write it again and again. Let's assume this proposition P is, my name is Deepak Punia. My name is Deepak Punia. So this is a proposition. You already know this is a proposition. So I denote it with propositional variable. This is known as propositional variable. Propositional variable. Propositional variable, basically this variable P, actually it is denoting, it is representing this proposition. So if anywhere I use this P, then it is basically just a representative of this proposition. Okay. Similarly, I can give you another proposition I teach discrete mathematics. Discrete mathematics. Now this again is a proposition. So you can see this proposition I have represented using this propositional variable Q. So this is again a propositional variable. This is just a representative of this proposition. So we do not want to write these long proposition again and again. Okay, so what we will do, we will use this propositional variable. So from now onwards, we will only use these propositional variable like P, Q, R. These are the propositional variables that we will use. Each propositional variable is representing some proposition. We do not care about that proposition. What is that proposition? We do not care. But we know that this P is a propositional variable. So this P is representing some proposition. And if that proposition is a true proposition, then we will say that the truth value of P is T. If that proposition is false proposition, then we will say that the truth value of P is false. So you can see these are propositional variables, and each propositional variable, for example this Q is propositional variable, this propositional variable can either be T or this can either be false. Okay. And actually there is a mistake in the previous slide, so do not focus on these statements. Like there is not necessary that this should be an English statement. Okay, like if someone is learning propositional logic in Chinese, then he will use Chinese statements. So like these things do not matter. Okay, but because we are taking only English statements, okay, so that's why we are basically only taking English statements, so I have written it here. But do not worry about these things, only worry about the definition of proposition, that proposition is nothing but a statement which declares a fact. Okay, तो आप हिंदी में बोलो, आप चाइनीज में बोलो, किसी में बोलो, अगर आप कोई एक ऐसा सेंटेंस बोल रहे हैं जो कि कोई फैक्ट डिक्लेयर कर रहा है, then that is a proposition. Okay, anyway, so we have seen some examples of proposition, we have seen some examples of some sentences which are not propositions, and and we have seen what is a propositional variable. So from now onwards we will use only propositional variables. Now if we have propositional variables, then we can connect two propositions. For example, as I told you, let's assume that this P is a proposition. Let's assume this P is a proposition. Today is Friday. Today is Friday. Let's assume this is today is Friday. Let's assume this is the proposition. Okay, and Q is the proposition. It is raining. It is raining. This Q is proposition. It is raining. Now this P is proposition. This P is a propositional variable which is representing this proposition. Q is a propositional variable which is representing this proposition. Now we will use this P, Q, and we will construct new proposition. For example, I can construct new proposition like this: P and Q. This will be a new proposition. What will be this proposition? It will be, what is P? P is today is Friday and it is raining. So that will be a new proposition. Today is Friday and it is raining. So that has become a new proposition. Similarly, I can create a new proposition like P or Q. What will be this proposition? It will be today is Friday or it is raining. Okay, so this is how we can construct new propositions from the existing propositions. Let's assume that P is an existing proposition, Q is an existing proposition. You have a proposition P, you have a proposition Q. Then you can construct new propositions by using some operators. Like this AND is a connective. This AND is basically a operator, operation, or you can say connective. Either you can say operation, or you can say operator, or you can say connective. Similarly, this OR is an operator or connective or operation basically. Now we have some operations, we have some connectives. Using those connectives, we can construct new propositions from the existing propositions. Okay, so for example, now what are the, like, let me tell you what are the connectives that we are going to see. So the first connective we are going to see is negation, and this is the symbol. So okay, let me write like here. So the first connective we are going to see is negation. This is the connective we are going to see. This is the name of that connective, and the symbol that we will use is this. This is the symbol we will use. So for example, if you have a proposition P, then you can construct a new proposition like this, negation P. Now this will be a new proposition, remember, this will be a new proposition, and basically if your proposition is P, then this will be not P. This will be not P. Okay. For example, let's assume that P is my name is Deepak Punia. This P is my name is Deepak Punia. Then what will be not P? Not P will be my name is not Deepak Punia. So that will be not P. So you can see, for example, let's assume P is today is Friday. That's P is today is Friday. Then what will be not P? What will be negation P? Negation P will be today is not Friday. Today is not Friday. So I can say basically not of P. Means I can say that not of today is Friday. So I can say today is not Friday. Okay. So this is how we have constructed new proposition. This was existing proposition, and this is we have constructed a new proposition. So this is a new proposition. So basically, if you have a statement, then you can construct a new statement using connectives. In everyday life, we construct new propositions using the connectives. Okay, so whenever we have a paragraph, the paragraph basically is like we write many things, and or these kind of connectives we use to connect two different propositions. So this is the first connective we will see, negation, and this is the symbol. So if the P is existing proposition, then this is a new proposition, not P. We will read it not P, and this is the symbol not P. Okay. Now some more symbols, some different symbols also can be used. We will see all those symbols very shortly. We will see. Now let me see if anyone has any doubts so far. Then let me see. Wait a second. So if anyone has any doubt, then you can ask in the chat comment box, and I will see and I will answer. Okay. So the next connective that we will see is AND. This is the next connective. This is also called conjunction. This is also called conjunction. This is another name basically. This is just the another name. And the another name is conjunction. And the symbol we will use is this. So for example, if P is an existing proposition, Q is an existing proposition, then this will be P and Q. This will be basically P and Q. This symbol will be, we will read this symbol as AND, P and Q. Okay. For example, if P is today's Friday, Q is this P. If this is today's Friday and Q is today's, it is raining, then what will be P and Q? It will be today's Friday and it is raining. So this is the next connective we will see. The next connective we will see is OR. It is also known as disjunction. It is also known as disjunction. So the symbol that we will use is this, P or Q. How we will read it? We will read it like this, P or Q. This is the next connective we will see. Okay, you can see basically you have a existing proposition, two propositions you have, and you have constructed a new proposition. This is a new proposition. The next connective that we will see is implication, and this is the symbol. What is the connective? Connective is implication. This is the connective that we will see, and this is the symbol. This is the symbol. So if you have a proposition P, if you have a proposition Q, then you can make a new proposition. P implies Q. We will read it like this: P implies Q. P implies Q. This is the new proposition. The next proposition connective we will see is biconditional. It is known as biconditional. Conditional. Okay, and this implication is also known as conditional. This implication is known as conditional. Okay, so you can see this implication is conditional and this is biconditional. So if you have a proposition P, if you have a proposition Q, then this will be a new proposition. P double implies Q. How we read it? Basically we will read it double implies. This is how we will read it, double implies. So we will read like this: P double implies Q. This is how we will read it. These are some these are most basic connectives that we will see. We will see one more connective we will see, that is XOR, and the symbol is this. We will see this connective also. We will see something called NAND. This is again a next connective that we will see, NAND, and the symbol is this. And we will see a connective NOR, and the symbol is this. Let's see all these connectives. So remember, if you have already studied Boolean algebra in digital logic, there is this subject digital logic, there you will study Boolean algebra. This Boolean algebra is exactly similar to propositional logic. I told you we are currently studying propositional logic, and yes, so currently we are studying propositional logic. But when you will study this Boolean algebra in digital logic, when this Boolean algebra will be taught, then you will see that this propositional logic is exactly equivalent to Boolean algebra. Okay, so all these things you will see there also. Right now we are using true. There, instead of true we will use 1. Right now we are using false. There, instead of false you will use 0. So basically that is the only difference. Here we are using true comma false. There they will use 1 comma 0. Okay, here we are using this symbol like P and Q. This is P and Q. There in Boolean algebra they will use P dot Q. Okay, so you can see very similar. There is a lot of similarity between propositional logic and Boolean algebra. And now all these operators we have seen the name of these operators. Now let's see the truth table and the behavior of these operators. So okay, let me tell you the behavior of these operators. So let's take one truth table, and in this truth table we will see the behavior of all these operators. So in the same truth table we will see everything. Let's assume you have P, Q. These are two propositions. Remember, these are just two propositions, existing propositions that you have. Okay, now you know there are some different cases possible. For example, maybe this P is false, this Q is false. Maybe P is false, Q is true. Maybe P is true, Q is false. Maybe P is true, Q is true. These are the different cases possible, right? If you have two propositions, then those propositions can either be false or they can be true. So how many different possibilities we have? We have total 4 different possibilities. Either both of them false, or P is false, Q is true, or P is true, Q is false, or both of them are true. So these are the different possibilities we have. Now if you have these existing propositions, then you can construct new proposition, and the first way that we will see to construct new proposition, that will be negation of P. What is negation of P? I told you this is negation of P. Okay, and let me write here. I will write all the symbols that we will use. For example, sometimes we will write like this. This will mean negation of P, or we can read it like this, not P. Sometimes we will use P dash. Remember, this is also same, P dash. This also means negation of P. Sometimes we will use P bar. This is also same thing. So all of these things are equivalent. Okay, you can either use negation of p, or you can use p dash, or you can use p bar. All these things are same. Now let's see, if p is false, then negation of p will be true, right? Because negation of p means not of p. Okay, for example, if I say that my name is Deepak, now this is a proposition. Let me call it proposition p. Then this is a true proposition. Now if I construct a new proposition, negation of p, then what will be that? That will be my name is not Deepak Punia. Now this is false. So you can see that if p is false, then negation of p will be true. Similarly, if p is false, then negation of p will be true. If p is true, then negation of p will be false. If p is true, then negation of p will be false. So you can see that truth value of negation p is basically just opposite of p. If p is false, then negation p will be true. If p is true, then this p dash will be false. So this is the behavior of negation operation. So this is the behavior of negation operation we have seen. This is the negation operation we have seen. This is the behavior. This is known as truth table. Why we call it truth table? Because it is telling us about the behavior of the operators that we are seeing. Okay. So the first operator that we have seen is negation operator, negation operation. Now the next operation we will see is p conjunction q. I told you that we read it like this, p and q. This is p and q. So sometimes we will call it p and q. This is also same thing. And sometimes we will call it p dot q. Why? Because in Boolean algebra we write it p dot q. This and in Boolean algebra we write as p dot q. Or sometimes we will remove this dot and we will directly write pq. So all these things are same. Either you can write p and q, or you can write p dot q, or you can write pq, or you can write p and this symbol q. Okay, all these things are same. Remember, all these things are same. Okay. Now this is a and the another name for this operation, for this AND operation, is conjunction. So you can also call it p conjunction q. P conjunction q. Okay. Now let's see what is p conjunction q. See, this conjunction means AND. Now if both are false, then it will be false, right? Because what we are saying p and q. If both are false, then it is false. If at least one of them is false, then it is false. It is true when both are true, because your statement is p and q. P and q. So when will this statement be true? It will be true when p is true and q is true. So that's why this is the truth table of conjunction. This is the truth table of conjunction. This is the conjunction operation we have seen. This is the conjunction connective we have seen, and this is the behavior. This is the behavior. So you can see that this p and q, it will be true when both p and q both are true. In all other cases, if at least one of p comma q, if at least one of them is false, then this p and q will be false. Now the next connective we will see is p or q. P or q. How do we read it? We read it like this, p or q. Sometimes we will write it p plus q. Why p plus q? Because in Boolean algebra we use this symbol plus. So this plus symbol we use in Boolean algebra. So we will sometimes write it like this, p plus q. Or we can write it like this, p disjunction q. Because I told you that another name for this is p disjunction q. Or we can use this symbol. Okay. So all these things are same. P or q, p plus q, p disjunction q, p, and this symbol. This is the symbol. This is the symbol for disjunction. What is this? This is basically saying that p or q. So it will be true if p or q is true. So you can see it will be true if at least one of them is true. So it will be true in this case, it will be true in this case, it will be true in this case. But in this case, when both are false, then it will be false. This is the truth table. Basically, this is the behavior of disjunction operation. This is the behavior of disjunction operation behavior we have seen. This is the behavior of disjunction operation. You can see it is false when both are false. In all other cases, it is true. The next operation that we will see, the next connective that we will see is conditional implication. What is the symbol that we will use? We will use this symbol, p implies q. What is how do we read it? We read it like this, p implies q. Okay, p implies q. or we can read like this: if P then Q. If P then Q. Basically we read it like this: if P then Q. Okay, or you can read it like this: P implies Q. This is called basically conditional or implication. This is known as conditional or implication connective. Okay, implication or conditional connective. What is the behavior of this connective? The behavior of this connective is very interesting. Just focus on the behavior of this connective. This connective is basically saying that if P then Q, means if P is true then Q should be true. Okay, so it is basically saying that if P is true then Q should be true. Now you see here both are true, so it will be true, because you can see if P is true then Q should be true. Now if you see this row, P is true, Q is false. In this case this P implies Q will be false. Why? Because this P implies Q is saying that if P is true then Q should be true, but Q is not true, so that's why it is false. Remember, it is saying if P is true then Q should be true, but it is not making any claim about what will happen if P is false. There is no claim. We are only saying that if P is true then Q is true. There is no claim regarding what will happen if P is false. So when P is false, then it will automatically become true. So this P implies Q, this will become true when P is false. So the truth table will be like this: true, true. So you can see that when P is false then it will automatically become true. So this is an interesting operation that we have, so you should focus on it. Next operation that we will see is biconditional operation. So biconditional operation, what will be the behavior of this? This means that P if and only if Q. How do we read it? We read it like this: P if and only if Q. This is known as biconditional operation. What is the truth table of it? It basically says that if both have same truth value then it will be true. For example, if both are false then it will be true. If both are true then it will be true. But if P, Q, if they have different truth value then it will be false. Okay, you can see if P, Q have different truth value then it will be false. This is the truth. So this is the complete behavior of all these 5 operators, and these are the most frequently asked operators. We have some more operators. Let's quickly see the truth table of those operators also. So again we have next operator, that is Xor operator. P XOR Q. It is known as P XOR Q. And what is the behavior of this P XOR Q? The behavior of this P XOR Q is like this. The behavior of P XOR Q is, it is basically saying that just opposite of that biconditional. That biconditional was saying that if both are false then it will be true, but this P XOR Q is just opposite of that. It will be true when exactly one of them is true. Basically one is true, another is false. In that case it will be true. In all other cases it will be false. The next operator that we have is P NAND Q. This is known as P NAND Q. What is P NAND Q? It is just AND negation. So it is basically negation AND. You can think of this NAND. You can read this NAND as not of AND. So first you do the AND. Okay, first you do the AND, then you do the negation. So basically just this is what we mean by NAND. NAND means first you do AND, then you do the negation. Okay, so what will be the truth table for this? So first you construct the truth table for P and Q, then you negate it. Okay, so finally basically we will get true, 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 false. You can see why? Because the truth table for P and Q was false, 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 true. So you just negate it. Okay, next is P nor Q. What is P nor Q? And this is the symbol that we will use. What is P nor Q? It is not or. Means first you do the or, then you do the not. Okay, first you do the or, then you do the not. So what will be the truth table? The truth table will basically just, it will be true, false, 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 because just negate the truth table for or. Okay, so this is the behavior of XOR, this is the behavior of NAND, and this is the behavior of NOR. Now, so someone is asking to repeat implication. See, implication has this behavior. This when basically this implication is what it is saying. It is saying that P implies Q. What it means? It means if P is true, then Q is true. Okay, if P is true, then Q is true. So it is basically we are only making a statement. What will happen when P is true? That is the only statement I am making. Okay, I am not making any statement about the situation in which P is false. I am not making any statement about the situation in which P is false. The only statement I am making is what will happen when P is true. I am saying that if P is true, then Q should be true. So you see here in the fourth row, you see P is true, Q is true. Then in this case, our statement is true because we are saying if P is true, then Q should be true. But if you see this third row, then what is this third row? P is true, Q is false. This is not what we want. Why? Because if P is true, then Q should be true. Q should be true. But it is not happening here. P is true, but Q is false. So in this situation, this our P implies Q, this will become false. And remember, in the remaining cases, when P is false, then automatically it will become true. Why? Because we have not made any statement about the situation in which P is false. So basically it will just be true. So this is the only situation we are interested. Basically, we are only interested in the situation in which P is true. If P is true, then Q should be true. Okay. So that is the behavior. Okay. So this is the behavior. I've just tried to actually remember. This is the definition of P implies Q. Okay. I have just tried to give you some intuitive idea about the this implication operator, but there is no requirement. Why? Because this is the definition. This is the way it has been defined. Okay. In your NET exam, they can give you a new operator. Okay, a new operator they can give you. Maybe they can give you a new operator like this. Maybe they can give you a new operator called hash. Now they will define what is the behavior of hash. They will have to define the behavior of hash. So right now, see, we have only defined the behavior of all the operators. We have all the operators. If you see, we have defined the behavior of them. Okay. In NET exam, maybe they can give you some new operator. If they give you a new operator, then they will define the behavior of that operator. So every operator has a behavior. Okay. So this is the behavior of implication operator. Implication operator, you can see only this is basically false in only this one situation, when P is true, Q is false. In this situation, this P implies Q will become false. In all other cases, it will be true. Okay. So any other symbol is there for NAND or NOR? NAND or NOR are not standard operators in propositional logic. Okay. So if they ask you any question from NAND NOR operator, then they will have to define the behavior of NAND comma NOR, because these are not standard operators. I have just given you this NAND NOR, but remember, these are not standard operators. The standard operators are negation, and, or, implication, by implication, XOR. These are the standard operators. NAND, NOR, these are not standard operators, and I have just given you the truth table of NAND NOR, but I did not need to. I gave you the truth table of NAND NOR because in Boolean algebra these are standard operators. In propositional logic these are not standard operators. Okay, so don't worry about the symbol for NAND comma NOR. Okay, if they use any different symbol, then they will have to give the definition of that symbol. 0 और 1 की फॉर्म में हम इसे 0 और 1 की फॉर्म में भी कर सकते हैं. मैंने बोला कि जहां भी ट्रू है उस ट्रू को आप 1 मान सकते हैं, और जहां पे भी फॉल्स है उसको आप 0 मान सकते हैं, क्योंकि प्रोपोजिशनल जो लॉजिक है वो बहुत सिमिलर है बूलियन अलजेब्रा के. आई टोल्ड यू प्रोपोजिशनल लॉजिक इज इक्विवेलेंट टू बूलियन अलजेब्रा. सो बेसिकली let me give you this. So I am saying that propositional logic is equivalent to Boolean algebra, and let me give you the complete description. Like in propositional logic, wherever we use t means true. In Boolean algebra we will use 1. In propositional logic, wherever we use false, in Boolean algebra we will use 0. In propositional logic we use negation of p. In Boolean algebra we will use p bar. Okay, this we will use. In propositional logic we use p conjunction q. In Boolean algebra we will use p dot q. Either p dot q will use, or we will directly write pq. Okay. In propositional logic we write p or p disjunction q. In Boolean algebra we will write p plus q. In propositional logic we write p double implies q. In Boolean algebra we will write XNOR q. P XNOR q, XNOR. Okay. In propositional logic we write p XOR q. In Boolean algebra we will again write p XOR q. This is same. In here also p XOR q, there also p XOR q. Okay. So these are the basic. You can see this propositional logic is exactly equivalent to Boolean algebra. So sometimes I can use like this, sometimes I can do also like this. If I do like this, then remember this means p conjunction q, and I can do like this. I can make truth table like this. Why? Because I told you basically this 0 means false, 1 means true. So what will be the truth table I will get? The truth table I will get will be like this. So this is the relation, this is the connection between propositional logic and Boolean algebra. These are exactly equivalent. Okay. Now let's see the next topic. So we have seen all these things, and now let's see the next topic. Before we go to next topic, let me give you one example how questions will be asked in these from these. For example, they can give you some formula like this: p conjunction q implies r biconditional p. Let's assume this is the formula. So they will give you a formula. This is known as a formula. Okay, so this is a propositional logic formula. We will call it propositional logic formula. PLF means propositional logic formula. Let's denote it with F. F means this F is a propositional logic formula. Now if I give you, tell me the answer. If P is true, Q is false, R is true. In this situation, what will be the truth value of F? What will be the truth value of F? Tell me, quickly try this question. Quickly try this question. What will be the truth value of F in this? Okay, let me. Okay, I should not write F because we are using this symbol F. So maybe I can write M. Let me write it M. So what will be the truth table of M? Truth value of M. M is this formula. This formula is known as. I'm basically denoting this formula as M. Okay. So this formula is M. What will be the truth value of M? Tell me. Quickly try this question. Yes. So let me. So you can try this question, and the answer will be. You can try. So what will be the answer? See. First of all, when P is true, Q is false. Then first of all, this P and Q. This P and Q implies R double implies P. See. When this P and Q, what will be it? It will be false. Why? Because P is false. Sorry, P is true, Q is false. So this P and Q will be false. So false. This will become false. What will be the truth value of this? R double implies P. So R is true, P is true. So double implies this also will become true. So this will become true. Okay, because both are true. So this R double implies P. This will also become true. Now we have false implies true. False implies true. This complete thing, false implies true. This will become true because you know the truth table of P implies Q. This is important truth table. So I am mentioning it again. The truth table of P implies Q will be, if both are false. Basically, when P is false, at that time it is automatically true. Basically, this if P is false, then automatically the P implies Q, this will become true. Okay, so the answer will be true. This is how they can ask you questions from this from these operators. Actually, this propositional logic is over when we study these operators, then automatically propositional logic is over. Okay, now we need to see some additional concepts. Some additional concepts we have, but the propositional logic, the major portion of propositional logic is already over. Okay, now let's see some additional concepts that we have. So those additional concepts we can see, and the first additional concept we have is something called well-formed formula. What is well-formed formula? This is not a like big thing. Just you have any formula, whatever formula you can make using these symbols. For example, this is a well-formed formula because this is a proposition. For example, this is a well-formed formula. For example, this is a well-formed formula. For example, this is a well-formed formula. Okay, for example, this P and Q implies R. This is a well-formed formula. Now what is not a well-formed formula? For example, this is not a well-formed formula. Why? Because you need this conjunction operation needs something here, something here, so you need to give something. So this is a well-formed formula, but this is not a well-formed formula. Similarly, for example, this is not a well-formed formula. Why? Because this disjunction operation needs something here, something it needs. Okay, this is a well-formed formula. Remember, this is not a well-formed formula because this negation should be applied here. So anyway, basically these are not important things. These are very basic things. What is a well-formed formula? They are not going to ask you what is a well-formed formula. And now let's see some normal forms. So we have two normal forms we have. Whatever formula I give you, let's assume that I give you a formula like this. If I give you a formula like this, if I give you a formula like this, okay, for example, if I give you a formula like this, maybe I can give you a different formula like this. Now you can see, or if I give you a formula like this, so you can see these are three type of formula I have given you. Okay, and now these formulas, this formula and this formula, they have a name. This formula do not have a name. These formulas do have a name. So these are known as normal forms. So some formula have some structure, some specific structure they have. Okay, some beautiful structure they have, some formula, and those formula are basically based on the structure of those formulas. We have two normal forms. One is PDNF, another is PCNF. Means principal disjunctive normal form, and another is principal conjunctive normal forms. Okay, so what is PDNF, what is PCNF? Let's see. So right now here, let's see. So if you remember, if anyone has, if you have already studied digital logic, then in digital logic you will study, don't worry, I will teach you, but in digital logic you will study something called SOP, something called POS, something called sum of product, something called product of sum. Okay, so you will study something like this. Okay, so these are same things we are going to study here. First of all, what is PDNF? PDNF means disjunctive normal forms. What is this disjunctive normal forms? This actually means this PDNF. This PDNF, basically this PDNF means disjunction of conjunction. Or I can say like this: sum of product. This is sum of product. Okay, means first you do the product, then you do the summation. First you do the product, then you do the summation. This kind of form is called as PDNF. Another we have PCNF. What is this? This is conjunction of disjunction. Remember, this is disjunction of conjunction, this is conjunction of disjunction. So I can write like this: product of sum. Okay, product of sum. Product means, you already know, product means conjunction. I told you this product word we use in the Boolean algebra. In propositional logic we use the word conjunction. This sum word we use in the Boolean algebra. In propositional logic we use the word disjunction. So I can say conjunction of disjunction. What it means? It means conjunction of disjunction. So you do the conjunction and inside you do the disjunction. So first you do the disjunction. Disjunction means internally you do the plus and outside you do the multiplication. Here sum of product means internally you do the product, and externally you do the summation. So this is like, okay, very easy it is. Don't worry, it is very easy. This is PDNF. D means disjunction. So you can say disjunction of conjunction means sum of product, summation of products. Similarly we have PCNF. PC means conjunction of disjunction, or you can say product of summation. Okay, now let's take one example. How let's understand this concept with example. Let's assume you have this formula. P. Let's assume that you have a formula like this, P or Q. Now this is the formula. Okay, now this okay, let me take some different example. Let me take a truth table and there I will take. So this P or Q. So what is truth table? Truth table is like this: 0 0 0 1 1 0 1 1. And what is the truth table? You already know. This is the truth table. Now if I want to construct the PDNF formula for this, remember this is a well-formed formula. This is a WFF, well-formed formula. For this formula I can convert this formula into PDNF form. How I will convert it? This PDNF form means SOP, means sum of product, summation of product. Okay, summation of product. So in this basically we focus on the terms these ones we focus. Okay, let me do one thing actually. Let me do this. Let me tell you that, okay, when you will study digital logic, at that time this concept, this SOP concept, this POS concept, this will be discussed in a very detailed manner. For one entire class, for 2 hours, this concept will be discussed. SOP, POS, this concept will be discussed in digital logic. So it doesn't make sense if we again repeat this concept here, because actually it will just confuse you, because I am quickly going over this concept, so it might confuse you. So let's do one thing. In digital logic, when you study SOP, when you study POS, these forms when you study, then just think that this SOP is PDNF, and this POS is PCNF. Okay, so once you study this concept, SOP concept once you study, POS concept once you study, for 2 hours you will study these concepts. These are very important concepts in digital logic subject, and digital logic subject will be taught after few days. This digital logic subject will be taught. At that time, once you study this SOP, then remember this one line, that this SOP is PDNF and this POS is PCNF. So there you will study this SOP. In SOP, what you will do, basically you will take these ones, and you will construct a SOP for these ones. In POS form, what you will do, in POS form you will take this 0 and you will construct a POS form for this 0. Anyway, right now I am not teaching you this concept, because this will again be taught in digital logic in a very detailed manner. So you learn it there, and just remember that this SOP means PDNF and this POS means PCNF. This is the only thing you need to remember. Once you study this concept there, automatically this PDNF PCNF will be over. Okay, so right now let's not discuss it. Maybe once this digital logic is over, then maybe I can take a small 15-minute class where I will give you some example of PDNF PCNF, because to study this PDNF PCNF, it is better that you study this SOP POS first. Okay, so right now let's skip it. Don't worry about this PDNF PCNF right now. In digital logic it will be covered. Okay, so now let's see the next topic, that is tautology, contradiction, contingency. Okay, So let's see the next topic we will see. So anyone has any doubt in this PDNF? Anyone has any doubt in this PCNF? Then just wait till this digital logic subject is over. There you will study POS SOP. There every concept will be covered, and after this digital logic is over, if you still have any doubt in the PDNF PCNF, then you can drop a message in our group, in our WhatsApp group, Acadflix WhatsApp group, in that group, crash course group. There you can drop the message and I will teach you. I will take some examples, and for 50, maybe we can take a half an hour session where I will take some examples and I will teach you these concepts, but actually you won't need it. Okay, so anyway, let's see the next concept, and the next concept is, let's so what is next concept that we will see? The next concept is satisfiability. This is the next concept we are going to see, satisfiability. What is this satisfiability concept? This satisfiability concept says that whether a given formula is satisfiable or not. Okay, so for example, consider now, right now I am going to give you some formula. For example, you already know this P comma Q, and what are the possibilities for P comma Q? These are the possibilities for P comma Q. You already know. 0 means false, 1 means true. Now if I write P or Q, what will be P or Q? This will be this. Okay, if I write P and Q, what will be this? This will be this. You already know all these things. If I write P or P bar, if I write P or P bar, what it will be? P or P bar, what it will be? It will be basically always true. Okay, why? Because you can write like this. What will be P bar? P bar will be 1 1 0 0, because if P is 0, then P bar will be 1. If P is 1, then P bar will be 0. We have already seen this thing. Now if P bar is this, P is this, then what will be P or P bar? What it will be? It will be 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 1 is 1. So you can see this will be 1. Now what will be P and P bar? What will be P and P bar? So what will be P and P bar? P and P bar will be 0 0 0 0, because 1 and 0 0, 1 and 0 0, 0 and 1 0, 0 and 1 0. So you can see this is all 0. You can notice few things. What are the things you should notice? If you see this formula, if you see this, let's call it formula F1, let's call it formula F2, let's call it formula F3, let's call it formula F4. If you see this formula F4, then this is always 0, always 0. This formula F4, it is always 0. Okay, so this formula F4 is known as contradiction. This is the word that we will use. So a formula which is always 0, a formula which is always 0, that formula will be called contradiction. A formula which is always true, if you see this formula, F3 formula, then this F3 formula is always true. So this will be called tautology. Tautology. Tautology means always true, because this formula F3 is always true. If you see formula F2, then this formula is sometimes false, sometimes true. So basically it is sometimes false, sometimes true. This type of formula which is sometimes false, sometimes true, this is known as contingency. Contingency. What is contingency means? A formula which is sometimes false, sometimes true. For example, if you see the F1 formula, then F1 formula is sometimes false, sometimes true. So this is also a contingency, because contingency means sometimes false, sometimes true. Okay, at least one time false, at least one time true. For example, this F2 formula, at least one time it is false, at least one time it is true. Similarly, this F1 formula, at least one time it is false, at least one time it is true. So these formulas, F1, F2 formula, these formulas are called contingency, because they are sometimes false, sometimes true. This formula F3 is called tautology, because it is always true, always true. This formula F4 is called contradiction, because it is always false. So if I give you a formula, then you can answer whether it is contradiction, contingency, or tautology. Let's take one example. I am giving you some formula. First formula that I am giving you, F1 formula that I am giving you is P. Tell me what it is. Tell me what it is. Is it contingency, tautology, or contradiction? What it is? This P. Is it contradiction? Is it tautology? Is it contingency? What it is? Anyone want to try? Okay, so yes, this is contingency. See, if you see this P, then this P can either be true. If you just write the truth value of just draw the truth table of P. What will be the truth table of P? Just draw the truth table of P. The truth table of P will be false, true. This will be the truth table of P. You can see this P can be false, this P can be true, right? So this P basically, okay, this is contingency. This is a contingency because it is either you can say it can be either false or it can be either true. Okay, we cannot say that it is always true. Remember, we cannot say, I will define it. Don't worry, Devika, I will define what is satisfiability, what is contingency, all these things I will define. Let right now just focus on contingency, contradiction, and tautology. See, when I give you a proposition, this P is a proposition. Of course, now you might say that this P is a proposition, so it has to be either true or it has to be either false. Yes, I am not denying that, but the thing is, you cannot say that it is always true. You cannot say that it is always false. Okay, so that's why it is basically a contingency. Okay, let's see next example. Let's see the next example, and that is P implies P dash. Tell me about it. P implies P dash. Tell me about it. Whether it is tautology, contingency, or contradiction. What it is? Tautology, contingency, or contradiction. Anyone want to try? This P implies Q. This formula F2. This formula F2. What it is? Contingency, contradiction, or tautology? Okay. Let's see. Let's draw the truth table for P implies P bar. What is P? P is again the same thing, either false or true. What is P bar? P bar will be true, false. So what will be P implies P bar? What will be? See, this P implies P bar, what it will be? It will be, in this case, you already know, in this case, when P is false, Q is true, then in this case basically it will be true. Because when this LHS side, this LHS of implication, when this LHS of implication is false, then automatically this complete thing will become true. In this case it will be false. So you can see sometimes true, sometimes false. So this is contingency. Remember, this is a contingency because sometimes true, sometimes false. Okay, let's see F3. P dash implies P dash. Tell me what it is. So again, this is contingency. This is contingency. Now tell me about this. P dash implies P dash. Is it tautology, contingency, or contradiction? What it is? No. Draw the table. Draw the table. See, what will be the table? Table will be like this. P is either false or true. These are the two possibilities for P. Then what will be the two possibilities for P dash? P dash will be true or false. Okay. Then what will be the P dash implies P dash? P dash implies P dash. Then this P dash implies P dash. So true implies true. See, in this case, when P dash is true, then true implies true. That will be true. False implies false. That will also be true. So you can see it is always true. So it is tautology. Okay. Any doubt? It is tautology because you can see it is always true. Okay. So this is the concept of tautology. This is the concept of contradiction and contingency. Now let's see the concept of satisfiability. What is satisfiable? Satisfiable. If you have a formula, then that will be satisfiable if and only if either it is tautology, or it is either tautology or contingency. Okay, so basically, if you have a formula and for that formula you just find out if it is tautology, then it is satisfiable. If it is contingency, then it is satisfiable. Satisfiable means tautology or contingency. Unsatisfiable means contradiction. So you can very easily find out now. Okay, you already know how to find out contradiction, contingency, tautology. Now you can just, if your formula is tautology or contingency, then your formula is satisfiable. If your formula is contradiction, then your formula is unsatisfiable. Okay, so let's take some more example. Before we take more complex example, let me give you some tips, some very important formulas I should give you. This P implies Q. This P implies Q. This is actually equivalent to P dash plus Q. Remember, this P implies Q is equivalent to P dash plus Q. Why it is so? You can very easily prove it. Very easily you can prove it, because what is P? So this is 0 0 0 1 1 0 1 1. This is your PQ. Now what will be P dash? P dash will be 1 1 0 0. You already know all these things. Then what will be P implies Q? P implies Q will be 1 1 0 1. This will be P implies Q. What will be P dash plus Q? What will be P dash plus Q? This is P dash, this is Q. What will be P dash plus Q? You can see 0 or 1 1, 1 or 1 1, 0 or 0 0, 1 or 0 1. So you can see one thing, that this is same as this. You can see this P implies Q. This is same as P dash plus Q. 1 1 0 1, 1 1 0 1. So this is very important. You can just star it. You can just triple star, 4 star. You can do whatever. This is very important formula, that this P implies Q. This can be written like this: P dash plus Q. Remember, basically what I am saying like this. You have a LHS side, implies you have a RHS side. This thing can be written like this. Whatever is your LHS side, you do the negation plus you do the RHS. Remember, P implies Q. You can write like this: P dash plus Q. What is this plus? This plus is disjunction. This plus is OR. What is this dash? This dash is negation. So you can see that this implication operator can be written in terms of negation and disjunction. This is negation. This P dash means negation, and this plus means OR, or we also call it disjunction. So this implication operator can be written in the terms of negation and negation comma disjunction. Okay, so this is how you can write. LHS implies RHS. So this is the implication operation. Okay, and this is the LHS side. This is the RHS side of this implication. Then what will be the formula? Do the negation of LHS plus RHS. This is a very important formula. Remember. Okay, so and what are some more formula that now, for example, if I gave you one example, P implies P dash, and I asked you whether it is tautology whether it is what it is, basically what it is, tautology, contradiction, contingency, then you can also solve it like this. First you convert this like this, this same thing you can convert like this, p dash plus p dash, because this is the LHS side, this is the RHS side. So what you will do, you will do the negation of LHS, so it will be p dash, plus you will add the RHS is already p dash plus p dash is already p dash. So that's why basically this is p dash. And now p dash is either true, or if this p dash is either false. So that's why it was contingency. Okay, so this is a very important formula, and some more things I can tell you. You might already know all these things, but let me tell you again. If you add 1 to anything, let's assume 1 plus p. This 1 means true, you already know, because basically this either you can write true, or sometimes you can write 1. You can write false, or you can write 0. All these things we are basically using interchangeably. Okay, so 1 plus p will be always 1, or I can say true plus p will be always true. All these things are same basically, because true means 1. Okay, so remember, true plus anything will be true. Okay, so this is important. True plus anything will be true. Similarly, the next thing is 0 dot p. 0 dot p, what it means? It means 0 conjuncts and. This is and. I told you that this p and q, this you can also write like this, p dot q, or you can write like this, pq. All these things are same. So this 0 dot p means 0 conjunction p. It means 0 p. What it is? It is 0. Finally, remember, 0 conjunction with anything is 0. Okay, or you can write like this, false conjunction p, because false means 0. All these things are same, because you already know that false is 0. But this conjunction sign, this can be written like this, dot also. We can use this dot also. So these are important. Next, p plus p bar is always true. This p plus p bar is always true. True means 1. So this p plus p bar is always true. P dot p bar is always false. You can actually remember, okay, there is nothing, you don't have to by heart all these things. You can prove them using truth table. So you can construct the truth table and you can prove them. For example, let's assume you want to prove it. How can you prove it? Very easily. Just construct the truth table. So false, true, then what will be p dash? P dash will be true, false. Then what will be p and p dash? What will be p and p dash? False and true, you already know false. True and false, you already know false. So you can see basically every time it is false. So that's why we are saying that p dot p dash is false. Remember, there is nothing to by heart. There is nothing to by heart here. Everything you can prove using this truth table. But I would suggest that you also know all these facts, so that you don't have to construct the truth table every time. Okay, so you should know all these facts, but you can prove all these facts using the truth table very easily. Next, what is the next thing? The next thing is you already know this, p implies q is basically same as p dash plus q. This you already know. This p implies q means p dash plus q. Also this p double implies q, this can be written like this. This can be written like this, p implies q and q implies p. This is how you can write this. Okay, let me take another. So you can write like this, p double implies q. This p double implies q, how can you write it? You can write it like this, p implies q and q implies p. This is how you can write. Okay, or how can you write this same thing, this p double implies q. I told you this p double implies q is nothing but the p XOR q. In Boolean algebra you will study p XOR q. There you will study this p XOR q, and this p XOR q, what it is? It is pq plus p bar q bar. So this is also how you can write this p double implies q. You can write like this, pq plus p bar q bar. Okay, this p XOR q, this you can write in Boolean algebra also you will study this, but you can write it like this, p dash q plus pq dash. Okay, so all these things you should know, and I have given you all these things. And remember, for example, this p and q, this is same as q and p, right? So this is known as commutative property. This is known as commutative property. Commutative property. What is commutative property? Commutative property means you can basically shift the these things like P and Q. You can write P, this P and Q you can write like this Q and P. Okay, for example, in mathematics you know that this 2 plus 3 is equal to 3 plus 2. So this addition in mathematics is commutative. This 2 plus 3 is same as 3 plus 2. So this addition is commutative. Remember, subtraction is not commutative. So this 2 minus 3, this is not same as 3 minus 2. So this subtraction is not commutative, addition is commutative. Similarly, multiplication is commutative. 2 multiplied by 3 is equal to 3 multiplied by 2. So multiplication is commutative. But remember, division is not commutative. For example, 4 divided by 2 is not the same as 2 divided by 4. So division is not commutative. But remember, this conjunction is commutative, this disjunction is commutative. Okay, but remember, this implication is not commutative. P implies Q is not same as Q implies P. Yes, so let me tell you, this P implies Q, remember, this is not the same as Q implies P. So this implication is not commutative. Why it is not commutative? You can very easily prove it. Just construct the truth table very easily. Just 0 1 1 0 1 1. What will be the truth table of P implies Q? The truth table of P implies Q will be 1 1 0 1. We have already seen it. What will be the truth table of Q implies P? This will be 1 0 1 1. This will be the truth table of Q implies P. You can see this is not same as this. This is 1 1 0 1. This is 1 0 1 1. So both are different. So remember, this P implies Q is not same as Q implies P. So we can say that implication is not commutative. You have to memorize this formula, or see, maybe there is nothing to memorize here. Everything you can prove. Either you can prove using truth table, all the basic concepts you can prove using truth table. I have given you the proof of many things. Right now I am not giving you proof of everything, but I am telling you that you can very easily prove it. Okay, and that's why I am doing what I am doing. For every 5-6 formula I am giving proof of one formula, so that you can just get the idea how you can prove it. For example, you can let me know whatever you want to see, the proof of whatever you want to see. I will give you the proof, but the thing is, I am not giving you proof of everything because of our time limit. Okay, there is not sufficient time till NET exam. So that's why what we are doing, I am doing this. I am giving you 5 formula, and then for one of those formula I am giving you proof, so that you get the idea that you can prove all these formula using truth table. You can do it yourself also. Okay, now let's see one example. Let's take this example. P implies Q implies R. Let's take this example. So now this, for example, in NET exam they will ask you this question. They will give you this question, and they will ask you, this formula is equivalent to which of the formula. So they will give you some options, A, B, C, D. These options will be given to you. Then how can you solve it? So you can very easily, first of all, maybe they can give you some formula. Let me solve it. This formula I can convert using this property. This property you already know. P implies Q is same as P dash plus Q. You already know this thing, so I can use it. So this P implies Q I will write like this: P dash plus Q implies R. Now remember, this is our LHS. Remember, this is our LHS and this is our RHS. So what I will do? I will do the negation of LHS plus RHS. Okay. So now I got this. If this is in the formula, then this is your answer. Let's assume option B is this. Then this will be your answer. Now further you can also do like this. There is a Demorgan property. Let me tell you a Demorgan property. What is Demorgan formula? This is also important. Demorgan formula. What is Demorgan formula? Demorgan formula is this: P conjunction Q bar is nothing but P bar over Q bar. This is Demorgan formula. P disjunction Q bar, this is P bar conjunction Q bar. This is Demorgan formula. What is Demorgan formula basically? Demorgan formula is very easy. If you are doing negation of conjunction, then the basically result, what will be the result? In the result, what you do, change this conjunction into disjunction. Remember, change this conjunction into disjunction and complement, basically negate each proposition. So this p will this p will become p dash, this q will become q dash. Similarly this disjunction will be changed to conjunction and this p will become p dash, q will become q dash. This is Demorgan formula. For example, if I give you this p dash or q dash, what it will be? It will be, all you have to do, change this disjunction into conjunction. So this disjunction will be converted into conjunction. This q will become q dash and this p dash will become p. This p dash will become p. So this will happen. So what I am saying basically, let me tell you, I am saying this Demorgan formula. Whenever you apply Demorgan formula, first of all, what is Demorgan formula? Demorgan formula is basically, if you have a formula, then how can you find the complement? Means how can you negate it? This is the Demorgan formula. So whenever you have a formula, let's assume this is your formula, some p, q, r, this is your formula. Now if you want to negate it, then what you will get? I told you, this conjunction will become disjunction, this disjunction will become conjunction, and this p will become p dash, q will become q dash, r will become r dash. So this basically, this thing is same as this thing. Okay, this is your Demorgan formula. Basically this conjunction will become disjunction, this disjunction will become conjunction, and every variable, every propositional variable p will become p dash. This is your Demorgan formula. Okay, this is your Demorgan formula. I can give you example. If you want to try, then you can try this question. Let me give you a question. Try this question. P dash q plus r bar. What it will be? Try this question. What it will be? Anyone want to try this question? Also, there is nothing to memorize these things. You can prove all these things, but it is beneficial that you also remember all these formulas, because it will save a lot of time. Okay, in exam you cannot prove things. If you start deriving, if you start proving things, then it will take a lot of time. So to save time, what you can do, you can when you are preparing, at that time you can try to prove these things, okay, very easily. I have given you proof of few things using truth table. I have given you the proof. So using truth table you can try to prove it, and but you should also remember all these facts, because they will save a lot of time. For example, this Demorgan formula, this formula you should also remember, because it will save a lot of time. Now let's see this, what it will be, what it is. You can, whenever you have a confused, whenever you have a doubt, remember, you can very easily just convert. For example, this, you can think of this p, this thing as a, you can think of this thing as a let's think of this thing as a plus r dash. What it will be? A plus r dash. A plus r dash will be a dash and r dash. You already know, because this disjunction will become conjunction. So a dash r dash. Now r dash is okay. What is a? A is p dash q dash. What is p dash q dash? It will be, you already know, because this is conjunction. This conjunction will become disjunction. This q will become q dash. This p dash will become p, and finally r dash. So this you will get. You can also write it like this. You can just multiply this inside. So you will get p r dash plus q dash r dash. This is also correct. So if you got this answer, then it is correct answer. Okay. Or p plus q dash dot r dash. So Prerna, it will be r dash. P plus q r dash. No, that is not correct. So anyone has any doubt after seeing this solution? Anyone has any doubt? Anyone has any doubt after seeing this solution? If anyone has any doubt, then you can ask. I have given the solution. This is how you can apply the De Morgan formula. Let me give you another example. Let me ask you another example. PQ plus QR dash whole dash. What it will be? What it will be? Try this question. Try this question. Try this question. Okay, let's see. See, I am giving the solution. Let's see once. This thing you can think of as a and this thing you can think of as a b. So basically this is nothing but a plus b dash. What is a plus b dash? You already know. A dash dot b dash. Now just find what is a dash. What is a dash? A is pq dash. B is qr dash dash. Now what is pq dash? Pq dash will be p dash plus q dash. What will be qr dash? It will be q dash plus r. So this will be your final answer. Okay, this will be your final answer. So this is how you can apply the De Morgan formula. Okay, so we have seen this De Morgan formula. Let's see more concepts. So this satisfiability concept is covered, because let me give you another question for satisfiability. I am giving you a formula. Let's call it formula F3, and this formula is this: P implies Q implies P. Tell me, this formula is satisfiable or not? This formula is satisfiable or not? Is this satisfiable or unsatisfiable? Tell me this. Is this satisfiable or unsatisfiable? I told you satisfiable means tautology or contingency, and I told you this unsatisfiable means contradiction. Contradiction means always false. Tautology means always true. Contingency means sometimes true, sometimes false. For this F3, you tell me whether this F3 is, what is this F3? Tell me. Try this question. The difference between contingency and satisfiability, Devika is asking. So you see, satisfiability means either your formula. So a formula, let's assume you have a formula. Let's assume you have formula G. So this formula G is satisfiable. Then it means G is either tautology. Okay, G is either tautology or G is contingency. So remember, satisfiable means tautology or contingency. So I can say that if formula is contingency, let's assume if formula is contingency, if formula is contingency, then I can say that formula is satisfiable. Because if your formula is contingency, then you can say that formula is satisfiable. But remember, if G is satisfiable, then you cannot say that G is contingency. Why? Because if G is satisfiable, then it can either be tautology or it can be contingency. Okay, so satisfiable means tautology or contingency. If your formula is contingency, then your formula is satisfiable. But if your formula is satisfiable, then you cannot say that your formula is contingency. Your formula can also be tautology. Okay, is this doubt clear, Devika? Is this doubt clear? So if your formula is satisfiable, then you cannot say that your formula is contingency, because your formula can also be tautology. But if your formula is contingency, then you can say that your formula is satisfiable. Now let's see this question. P implies Q implies P. So this is your question. P implies Q implies P. Very easily you can solve it. First you cover it. What is it? It is P dash plus Q. You already know this thing. P implies Q can be written like this. P dash plus Q implies P. Now this is LHS. This is RHS. So again what you can do? This LHS dash you can do plus P. What is this? Here you can apply the Demorgan formula. When you apply the Demorgan formula, then you will get P Q dash. This you will get, because this disjunction will be converted into conjunction. This P dash will become P, this Q will become Q dash plus P. P plus PQ dash. How can I write it? You can take the P common, then you will get P dash plus 1. You already know this. This I have told you this Q dash plus 1. This is 1. I told you that this anything plus 1 is 1. So it will be P. Finally the result will be P. So basically this formula is nothing but P, and this P is contingency. This P is contingency because P can either be true or P can either be false. So the P is contingency. I told you, I have already mentioned this example that this P is contingency. So because your formula is contingency, so you can say that your formula is satisfiable. I asked the question that is it satisfiable? So yes, it is satisfiable. Why? Because it is contingency. So yes, it is satisfiable. Okay, satisfiable and contingency, right? Amandip, yes, correct. Satisfiable and contingency. It is not tautology, remember, it is not tautology, it is satisfiable, also it is contingency. Because it is contingency, so you can say that it is satisfiable. Okay, so this is how you can very easily you can solve questions, and if you want to try, then we can take more examples, but let me go through the remaining concepts. So I told you this PDNF PCNF concept you can study in digital logic. When you will study SOP POS, sum of product of sum, there you can study this concept. Basically I told you that I have mentioned basically everything. Okay, that this PDNF is nothing but SOP, this PCNF is nothing but POS. So you will study it there. This tautology, contradiction, contingency, everything we have covered. Okay, now let's see the next concept. Let's see what is the next concept. The next concept is converse, inverse and contrapositive. Converse, inverse and contrapositive. This is the next concept. What is this concept? Let's see. If you have a conditional statement, if you have a conditional statement, if you have a conditional statement, P implies Q. You already know what is conditional statement. This P implies Q. This is known as conditional statement, or we can say this is known as implication statement. So this is known as conditional statement. We have already seen this thing. So this P implies Q. If you have this statement, P implies Q, and I already told you this P implies Q. How do you read it? You read it like this: if P, then Q. This is how you read this P implies Q. You can read like this: if P, then Q. Okay, so this is your original conditional statement. Let me call it original conditional statement. Let's assume right now in your hand you have this conditional statement, this P implies Q. This is the conditional statement that you have right now in your hand. Now you can cook more conditional statements. From this conditional statement you can derive more conditional statements. This is original conditional statement. Now you can construct converse of this. So what will be the converse of this? Converse of a conditional statement. What is the converse? The converse will be basically Q implies P. This will be the converse. Remember, original conditional statement is P implies Q. The converse will be Q implies P. How do we read Q implies P? We read like this: if Q then P. This is basically converse. Remember, the original conditional statement is if P then Q, and this converse will be Q implies P, means if Q then P. This is the converse. This is how we find converse. Remember. Now, how can we find inverse? Inverse of a conditional statement. So the original conditional statement, remember, for this original conditional statement I am finding inverse. Okay, for this original conditional statement I am finding inverse of this conditional statement. What it will be? It will be negation P implies negation Q. This will be the inverse of this conditional statement. This negation P implies negation Q. Okay, this is how you can find inverse of this conditional statement. How can you find contrapositive? How can you find contrapositive? Contrapositive of this original conditional statement will be not Q implies not P. So remember, if your original conditional statement is P implies Q, then you can find converse. Converse will be Q implies P. Inverse will be not P implies not Q. Contrapositive will be not Q implies not P. So these are basically the concept of converse, inverse, contrapositive. Okay. Now let me construct the truth table of all these statements. So let me construct the truth table. If you have PQ 0 0 0 1 1 0 1 1, this is your PQ. Then what will be original condition? This is original conditional statement. P implies Q. Remember, this is original conditional statement. Conditional statement. P implies Q. So what will be the truth table of P implies Q? You already know all these things. 1 1 0 1. Now what will be the converse? You already know what is converse. I have defined it. Converse will be Q implies P. What will be the truth table of Q implies P? This will be 1 0 1 1. This will be the truth table of Q implies P. Q implies P. Okay, so the Q implies P will have this truth table 1 0 1 1. Now what will be the truth table of inverse? Inverse, you already know what is inverse. Inverse means not P implies not Q. So not P implies not Q. So what will the truth table of not P implies not Q? You can very easily construct. So first you just construct the not P not Q column. So not P not Q column you can construct, and you can just very easily construct this truth table. So the truth table that you will get will be this. This is the truth table that you will get. Next we have contrapositive. What is contrapositive? That is not Q implies not P. Not Q implies not P. Not Q implies not P. And the truth table, if you find for contrapositive, then you will get 1 1 0 1. This is the truth table you will get. You can try it. Okay. After this class, you can try, and you will get this truth table. Few things you should note. What are the things you should note? If you see the original conditional statement, that is 1 1 0 1, and if you see the contrapositive, that is also 1 1 0 1. So first thing you can notice is that P implies Q. This is the original conditional statement. Remember, this is the original conditional statement. This is equivalent to its contrapositive. What is contrapositive? That is not Q implies not P. Remember, this original conditional statement is equivalent to its contrapositive because both have same truth table. Second thing you can note is this converse has this table 1 0 1 1. This inverse also has this table 1 0 1 1. Okay, so this converse and this inverse both have same truth table. So what can you say? You can say that converse of a conditional statement is equivalent to inverse of that conditional statement. Okay, did you get this point? I am saying that converse of a conditional statement is equivalent to inverse of that conditional statement. So that is the second point. What is the third point you can observe? If you observe, then this original statement has this truth table 1 1 0 1. and the converse has this truth table 1011. So both are not same. This is 1101, this is 1011. So both are not same. So what you can say? You can say that original conditional statement is not equivalent to its converse. Okay, original conditional statement. This is original conditional statement. It is not equivalent to its converse. This is the next thing you can observe. The fourth thing what you can observe is that if you see, this is the original conditional statement 1101. This is the original conditional statement, and this is inverse 1011. This is inverse. This is 1101. This is 1011. So both are different. So you can say that original conditional statement is not equivalent to its inverse. Its inverse. So these are the fact you can observe from this truth table, and the important fact, actually few 4 or 5 fact you can derive from this table. But the most important fact is that any conditional statement is equivalent to its contrapositive. So P implies Q, this P implies Q is equivalent to not Q implies not P. Okay. Also this is also important, that conditional statement is not equivalent to its converse. So P implies Q is not equivalent to Q implies P. So these things are important observations from this. So in these slides also you can, in these slides we have basically taught tautology, contradiction and contingency. Okay. So if this point is clear, then I can ask you some questions. Let me ask you a question. The question that I am asking, question 1. So this is like this. I am giving you a conditional statement. Okay, and that conditional statement is P implies Q implies P. This is your conditional statement. Remember, this is the conditional statement I am giving. Let me call it F4. So this F4 is a conditional statement. Why? Because this is LHS, this is RHS. Okay, so this is your F4. First question I am asking, the question, so some questions I can ask. First question, is it satisfiable? Is it satisfiable? Try this question. Is it satisfiable? Yes or no? Is it satisfiable? Yes or no? Yes, Devika. Inverse of a conditional statement is equivalent to converse of a conditional statement. Yes, this is correct. Padam, which condition should I repeat? Sir, 2 conditions. The second condition is, Devika has already written that this inverse of a conditional statement is equivalent to converse of a conditional statement. From the truth table we can see. Now the question is this. Okay, focus on this question, F4. Is this F4 satisfiable? This is the first question. F4 is satisfiable or not? So let me solve it. Yes, this is satisfiable. Why? What you can do, either you can solve it using truth table. Let me give you the first solution. The first solution I will give you using truth table. Let me give you the solution. Truth table, using the solution. Sorry, using the truth table, let me give you the solution. This is the solution using truth table. So PQ, what is P implies Q? The truth table of P implies Q you already know. This will be 1101. What will be the truth table of Q implies P? This will be 1011. This will be the truth table of Q implies P. Finally, if you want to make the truth table of P implies Q implies P, so means this thing implies this thing. What will be the truth table? So this thing implies this thing. The truth table will be 1 1 true, 1 0 false, 0 1 true, 1 1 true. This will be the truth. So finally, if you see, for this F4 formula, you can see the truth table is 1011. So sometimes it is true, sometimes it is false. So it is a contingency, remember. So it is a contingency, remember. So this F4 formula is a contingency, and because it is a contingency, so you can say it is a satisfiable. So yes, it is satisfiable. So first question, is it satisfiable? Yes, because it is a contingency. Remember, this is a contingency. Okay, so this is your first question. Now the second question I can ask you. So F4 is same, P implies Q implies Q implies P. This is your F4. Now the second question I am asking B is, can you find converse? Find the converse of this, converse of F4. What will be the converse of F4? What will be the converse of F4? Can you find the converse of F4? What will be the converse of F4? If in option both contingency and satisfiable is given separately, then which option to mark? So Devika, such situations will not happen. Okay, they will take care. These questions will be made by professors. These questions will not be made by these coaching institutes. The professors will make papers. So don't worry about such things. You only focus on your concepts. Okay, the only thing you need to focus is your concept. See, Mona Nidhi, I am just asking converse. I am not asking the truth table. I am only asking the converse of this F4. So the converse of F4 will be, what will be the converse of F4? I told you that this is a conditional statement. This is LHS implies RHS. This is LHS. This is RHS. Then what will be the converse? Converse will be RHS implies LHS. RHS implies LHS. This will be the converse. Okay. See, now I can find the inverse also. Inverse. What will be the inverse of F4? The inverse of F4 will be negation of LHS. Negation of LHS implies negation of RHS. This will be the inverse. And what will be the contrapositive? What will be the contrapositive of F4? Contrapositive F4 will be negation of RHS implies negation of LHS. Negation of LHS. This will be the contrapositive of F4. So remember, whenever you have a formula like this, LHS implies RHS, whenever you have a formula like this, then the converse of this formula will be RHS implies LHS. The inverse of this formula will be negation of LHS implies negation of RHS. The contrapositive of this formula will be negation of RHS implies negation of LHS. So this is how we find it. This is how we find converse, inverse, contrapositive. And you already know all these things, that every conditional statement is equivalent to its contrapositive. Okay. So if anyone has any doubt, then you can quickly ask. Now let's move on to the something called arguments. Let's see the next topic, something called arguments. What is arguments? The next concept that we are seeing right now, we are seeing the next concept, argument. Argument in logic, argument in propositional logic, how it works? It works like this. You have some statements. Some statements are there. Maybe statement P1, statement P2, statement P3. Some statements are there. Maybe P1, P2, P3. These three statements are there. Then there is a conclusion. Conclusion C. So some statements are there and there is a conclusion. So these are called These are called basically the hypothesis. These are basically the hypothesis. These are called hypothesis, and this is called conclusion or consequence, conclusion. So you have three statements, and the conclusion of three statements is this C. So remember, this is very important, like very easy. Okay, very easy. In day-to-day life also we do arguments. We give some, first of all, what we will do, we will give some fact. Okay, we will say that okay, this government has done this. Okay, this government has done P1, this government has done P2, this government has done P3. Then we draw a conclusion that this government is bad, or maybe this government is good. These kind of conclusions we draw. Okay, so this kind of arguments we also have in our day-to-day life. Every day we have these kind of conclusions. Okay, so in logic also, in propositional logic also, we have this kind of conclusion, this kind of argument. This complete thing is called argument. So first you give your first you give your dalil. Okay, in Hindi if you see dalil, in court language if you see dalil means first you give your arguments, or all the claims you give. So these are the claims. Then you give your conclusion. Okay, so this complete thing is known as argument. So these are the hypothesis, P1, P2, P3, these are hypothesis, and this C is a conclusion. Now either this argument is valid or this argument is invalid. Of course, you can see in day-to-day life many people make valid argument. Sometimes you say, right, okay, these kind of statements you use, okay, your argument is valid. Sometimes you say your argument is not valid. These kind of statements you use. So here also we have this kind of thing. We have something called valid argument, and we have something called invalid argument. Invalid argument. What do we mean by valid argument? See, you have these premises, this hypothesis you have, P1, P2, P3. These are the hypothesis you have, and this is the conclusion you have. This complete thing is argument. This complete thing is argument. When you say that this is a valid argument, then it means that from these hypothesis, from these three statements, P1, P2, P3, the conclusion follows. So if these things are true, then this conclusion is true. Okay, if these things are true, then this conclusion is true. So I say that this is a valid argument. What do I mean by invalid argument? Invalid argument means if these things are true, then this C may or may not be true. Okay, this C may or may not be true, means basically this is an invalid argument. Okay, don't worry, we will take example and we will understand it. Let me give you first example. The first hypothesis I am giving you like this: P and Q. This is my hypothesis, P and Q. This is a hypothesis, and the conclusion is P. Remember, this is my hypothesis and this is my conclusion. So this is my hypothesis, P1. Only one hypothesis I have. Okay, I don't have more than one hypothesis, only one hypothesis, and there is only one conclusion. So this is hypothesis, and this complete thing is known as argument. This complete thing is known as argument. Now let's find out whether this argument is valid or not. So I told you that this argument will be valid if this hypothesis implies conclusion. Means if this hypothesis implies P, if this thing is tautology, remember, if this thing is tautology, if this thing is tautology, if this thing is tautology, if this formula is tautology, then we will say that argument is valid. Then we will say that argument is valid. Remember, so it is very easy. You have an argument. This is your argument. This is hypothesis. This is conclusion. This complete thing is argument. Now what you do? We say that this argument is valid if this hypothesis implies this conclusion. Means this hypothesis implies this conclusion. Means this complete thing, if this is tautology, then you will say that it is argument is valid. And remember, if this thing is not a tautology, if this is not a tautology, then you will say that argument is invalid. Argument is invalid. This is our basic thing. Let's try to find out whether this is, let's see whether this argument, the argument that we have taken, whether this argument is valid or not. So very easily you can find out. Just see whether this formula is tautology or not. What you can do, you can This LHS implies RHS. How can you write it? You can write like this: LHS LHS negation plus RHS. You already know this thing. Now from here, what you can do? You can apply the Demorgan formula. What it will be? P dash plus Q dash. So basically, this will be P dash plus Q dash plus P. Remember, we have already seen this thing: P plus P dash. This P plus P dash. This is always true. So this P plus P dash will be true. True plus Q dash. True plus Q dash will be true. All these things we have already seen. So finally you got true. Means this formula, if you see, this formula is true. Means this is always true. Because this formula is true, means this is always true. So this is a tautology because this formula is true. So if this formula is true, means this formula is tautology, then this argument is valid. So this argument is valid, remember. Okay, this is how we can find whether a given argument is valid or not. Let's take one more example. For example, P and Q, P then not Q. This is next example. Remember, here we have two hypotheses. P1, this is the hypothesis P1, this is the P2 hypothesis, and this is the conclusion. So this complete thing is known as argument. So this complete thing is argument. Just wait a second. Okay, so what I am saying that this is your argument where you have two hypotheses and this is the conclusion. Now let's find out whether this argument is valid or not. All you have to do, just see that this P1 and P2, this should implies conclusion. I told you this argument will be called valid if these hypotheses imply this conclusion. Means P1 and P2 should implies C. So this thing should be tautology. If this thing is a tautology, then argument is valid. If this thing is not tautology, then argument is invalid. Okay, let's see whether what will happen. So what is P1? P1 is nothing but P and Q, and P2 is P. P and Q and P implies not Q. You already know this. This P and Q is basically nothing but P. Similarly, P or Q. This P plus Q is also P. You already know all these things. We have already seen it. So this P and P. This P and P will be P. So basically, this will be P and Q implies not Q. Now you can again convert this implication. So how? This is LHS. This is RHS. LHS implies RHS. We can write like this: LHS dash plus RHS. What is this? Here you can apply the Demorgan formula. So you will get P dash plus Q dash plus this is, what is this? This is Q dash. What is Q dash plus Q dash? Q dash plus Q dash is Q dash. So you will get P dash plus Q dash. So remember, finally you got a P dash plus Q dash. Is this P dash plus Q dash a tautology? No, this is not a tautology. Why? Because it is not always true. This P dash plus Q dash, this is not always true. Okay, for example, if P is true, Q is true. Let's assume P is true, Q is true. In this case, P dash will be false, Q dash will be false, false plus false will be false. So you can see that this is not always true. So this is not a tautology. Because this is not a tautology, so this argument is invalid. This argument is invalid. Okay, so this is the concept of argument. This is how you can find whether a given argument is valid or not. Okay, all you have to do, whenever you have some argument, let's assume you have some argument, you have in argument you have some hypothesis, P1 hypothesis, P2 hypothesis, P3 hypothesis, P4 hypothesis, and let's assume there is a conclusion. All you have to check whether this argument is valid or not, all you have to do is this: just make this formula P1 and P2 and P3 and P4. This basically, these hypotheses must imply this conclusion. Means this thing must imply C. This complete formula, if this complete formula is tautology, then you will say argument is valid. If this complete formula is not tautology, then your argument is invalid. Okay, so this is how we find whether an argument is valid or not. Okay, so this is our concept of valid or invalid argument. And so now our propositional logic is over. Tomorrow we will start predicate logic. I told you two type of logics we have. The one is propositional logic and another is predicate logic. So we have seen so far propositional logic, all the concepts of propositional logic we have seen, we have covered. And the in the mathematical logic, the next type of logic that is remaining is predicate logic. Okay, so so this predicate logic we will see tomorrow. And let me see if anyone has any doubt. Then let me see the, if anyone has any doubt, then you can ask right now. Quickly ask if anyone has any doubt. Devika, what is your doubt? Sir, last question. On which? This last question, which question you are asking? This is just the concept. Oh, I'm not getting which concept, which question you are asking. Okay, let me have one more question. Let me have one more question on arguments. Okay, let's see one more question. So let's see this. Let's assume that you have this is your hypothesis P or Q. This is your hypothesis and this is your conclusion P. Tell me, is this argument valid? This complete argument, is this complete argument valid or not? Tell me, valid or not? Try this question. Devika, try this question. Okay, let's do one thing. You can, Devika, you can ask your doubt on the WhatsApp. You can ask, and I'll answer it. Right now, I'm not getting which question you have doubt. So let's do one thing. Try to solve this question where you proved formula is valid. Okay, see, I did not prove formula is valid. I gave the definition of, that was not a proof, that was definition of how we will say whether an argument is valid or not. Okay, so first try this question and then we will see again. We will see it again. Don't worry. I will tell you again what is the definition of argument, validity of argument. What is the definition? We will see. Let's solve this question. Is this argument valid or not? Yes or no? Is this argument valid or not? Yes or no? Okay, so because we have less time, so we do not have time already. The time is over. So let me solve it quickly. This is our hypothesis. This is our conclusion. Remember, this is our hypothesis P1, and this is our conclusion. And if you want to find, Devika, focus on this here. If you right now, I will tell you the definition of validity of argument. So if you have hypothesis, you have conclusion, then when we want to find out whether this argument is valid or not, if we want to find out whether this argument is valid or not, then what we should do, we should make this equation P1 implies conclusion. This equation we should make, and this equation we should try to find whether it is a tautology or not. If it is a tautology, then this argument will be valid. If this is not a tautology, then this argument will be invalid. This is the definition. Remember, this is not a proof. This is just a definition of this is just a definition of validity of argument. Okay, so you first make this formula P1 implies C. What is P1? P1 is this is your P1 implies C. What is C? C is P. P or Q implies P. Now let's try to find whether this formula is tautology or not. So what you do, you just convert this formula. I told you this the LHS implies RHS. This is LHS. This implies RHS. LHS implies RHS. So what you can do? You can do like this: LHS dash plus RHS. Okay. Now here you can apply the Demorgan formula. So you will get P dash Q dash plus P. You will get P dash Q dash plus P. Now this, just look at this, P plus P dash Q dash. You can also try, if you want, you can also make the truth table and you can see 0 0 0 1 1 0 1 1. And if you make the truth table for the, what will be P dash, what will be Q dash, this P dash will be basically 1 1 0 0 and Q dash will be basically 1 0 1 0. This is P dash Q dash. So what will be P dash Q dash? The P dash Q dash will be 1 0 0 0. This will be P dash Q dash. What will be P dash Q dash plus P? What will be P dash, this P dash Q dash plus P? What it will be? It will be 1 0 1 1. So you can see that this P plus P dash Q dash, this P plus P dash Q dash, this is basically not a tautology. Why? Tautology means always true, but this is not always true. This is not always true. So this is not a tautology. So because this is not a tautology, so this argument is invalid. This argument that you have, this is invalid argument. Okay, did you get it? And let me redefine, let me repeat the definition of argument, validity of argument. What is an argument? In argument, what you have, some hypothesis you have, P1, P2, P3. These are the hypotheses. Let's assume you have 4 hypotheses. P1, any number of hypotheses you can have. P1, P2, P3, P4. These are the hypotheses you have. And this is the conclusion you have. Okay. So this is the hypothesis you have and this is the conclusion you have. Now this complete thing is known as argument. Let's call it argument A1. Let's call it argument A1. Now to find out whether, what you do to find out whether this argument A1 is valid or not, what you have to do is, these hypotheses should imply this conclusion. What I mean like this: P1 and P2 and P3 and P4. These hypotheses, basically this P1 and P2 and P3 and P4, this should imply conclusion. Okay. Now this formula you have constructed, okay, this formula you have constructed, just check whether this formula is tautology or not. If this formula is tautology, then this argument A1 is valid. If this formula is not a tautology, then this formula A1 is invalid. This is how we define validity or invalidity of a argument. Okay, any doubt, Devika? In this definition, do you have any doubt? I have repeated the definition of validity of argument. Prerna, we will provide topic-wise questions. Okay, we will provide topic. So on this propositional logic, all the net questions will be provided, and you can solve those questions. Okay. Anyone has any suggestion? Anyone has any doubt? Anyone has any feedback? Anyone has anything to say? Then you can say. The lecture is over. Tomorrow we will start predicate logic. The propositional logic is over. All the concepts of propositional logic is over, and tomorrow we will start something called predicate logic. If anyone has any doubt, any suggestion, any feedback, that you can tell me right now, or you can write your doubt on the WhatsApp also. You can ask your doubt. Okay. Okay then everyone, I think no one has any doubt. Thank you. Okay, thank you Monica, thank you Prerna, thank you everyone. So see you in the tomorrow's lecture. Sir, class lecture के notes मिलेंगे. So these slides, okay, I'll ask Abdul sir, and we can provide these slides also. I'll send you the doubt in WhatsApp. Okay, yes, okay David. Okay, thank you everyone, and tomorrow we will start predicate logic. And remember, this predicate logic has all the features that are there in the propositional logic. So today's class is important for tomorrow's class. So if you have any doubt in today's class, then you can ask, or you can rewatch this recording anywhere. If you have any doubt, then you can rewatch this recording, because in tomorrow's class we are going to use all these concepts. Okay, we will use all these concepts again in tomorrow's class. So that's why I am saying that you should be comfortable with propositional logic. You should be comfortable with today's class. If any doubt is there, you can ask on the WhatsApp. Okay, and all these language problem and all these things, all these issues, if there is any issue that you have faced, then you can let us know on the WhatsApp. You can let us know and we will resolve it. Okay, so provide your feedback, provide your suggestions, provide let us know your what are the issues that you have faced. If you have any technical doubt, then you can ask. We are here to support you in all your doubts, in all your queries. Okay everyone, thank you. And okay then,